Hello, in this one, let's take a look at some basic relationships between the sides of a triangle, specifically the triangle inequality. So here I have a triangle. This is a basic 3, 4, 5 triangle. So take a look. The hypotenuse, the long side is 5 units, the bottom is 3 units in green, and the vertical side is 3, or rather 4 units in blue. Take a look. Is 5 less than 4 plus 3? Well, it's 5 less than 7 really. That's what we were asking. That clearly is a true result. What is that telling us? It's telling us that this side right here, the red side of the hypotenuse, is less in length than the sum of the green side and then also the blue sides put together. Take a look at the next piece. Is 4 less than 5 plus 3? Well, yeah, because 4 is less than 8, in other words, because 5 plus 3 is 8. What is that telling us? It's telling us that the blue side is smaller in length than the sum given by adding up the red side and the green side. And you can tell that, I think, intuitively just by looking at the shape. If you were to measure the blue side, for example, with a ruler, you would see that it's clearly less than the sum of the green and the red sides. That's all. The last relationship, for example, could say that 3 is less than 5 plus 4. Well, that makes sense. So 3 is the bottom side here. And you see that, well, 5 plus 4 is 9, so clearly 3 is less than 9. That's a true result. So this is an observation that you can make about a triangle like this one. And notice that, in other words, this is giving us a clue as to a test that you can apply to see whether 3 numbers make a triangle. You want to have it so that the length of any particular side is less than the sum of the other 2 sides. That's the key concept. Let's take a look at this next stage here. So here I have 3 numbers given, 4, 2, and 3. What I want to know is whether these can make a triangle or not. So I just have to do some basic checks as follows. Is 3 less than 2 plus 4? Well, in other words, is 3 less than 6? That is clearly true. I'm just checking. I'm taking each value like the 3 and I'm checking whether it's less than 4 plus 2. I go on to the next one. So is 2 less than 3 plus 4? Well, is 2 less than 7 in other words, since 3 plus 4 is 7. That is also true. Next one. I'll get to the circle in a minute. You'll see why I need that. At the bottom here it says 4 less than 3 plus 2. Well, it's 4 less than 5 really. That is also true. So we have discovered that each of these values in the list here, 4, 2, 3, is less than the sum of the other 2 values. Now the question is, how do you make a triangle so that it looks good? For example, using a piece of paper and maybe just something that allows you to draw circles rather than actual triangles, so that it's like really good. So this is a slight kind of mathematical aside, a way to construct these triangles, a construction approach. Take a look. Take that small number, for example, of 2, and draw a circle on your paper of radius 2. And then draw another circle, the bigger one here, of radius 3, for example. And then lastly, grab a point on the circle, on the bigger circle, like this point here. It could be a point anywhere on that bigger circle. It doesn't really make any difference. So I just chose a random spot right here above my head on the bigger circle. And at that center, draw a circle of radius 4. So draw a circle of radius 4, look, just like that. Why would I do all of this? It seems like a crazy amount of stuff to do just to draw a triangle. And you'd be right. Except if you're really interested in producing a good quality triangle, take a look at what happens. You see, you're going to draw from the center of the small circle to where these two intersect. That's the intersection point of the big circle, radius 4, and the small circle, radius 2. And now look carefully. Then you're going to draw this next one here. Where is that? Well, that is the side 3. 3 units in length. You see, because it goes from the center over to that point. And now you can probably predict what will happen last. Take a look. You can draw that third side, but that third side, think about it, right? That blue point is the center of the big circle, and it reaches all the way to the circumference of the big circle, which means that that length has to be equal to 4, right here. And using 3 circles, you can construct a triangle like this perfectly, like magic. Let's do another example here. Take a look. Let's move on. Another thing that you can do that is this one. There's nothing special about always just constructing it the way I just showed you. So what I mean is this. Take a look. Draw that same 2 unit, for example, circle. Another circle with a radius 3 units. Again, choose that point across the top. Again, it could be a point anywhere on that circle. Doesn't have to be across the top, really. And then draw that circle of radius 4, and now look carefully. Again, this time draw a line, if you like, from the center of the smallest circle to where they intersect over here. The big circle and the smallest circle, where they intersect, on that side. And again, draw a segment from the center over to that top point. You see right here? Lastly, connect as follows. This way. So from that point over to this point where they meet. And again, you get a beautiful perfect triangle, and you're guaranteed that will be 4 units right here. Obviously, doing this freehand can be a bit rough, right? So if you have a basic instrument that allows you to draw circles, then you can really make this perfect. Take a look. There's one more case that could be interesting to consider, which is this one. Imagine you have just these numbers, 2, 2, and 3. So can you make a triangle out of 2, 2, and 3? That's the question. So let's do the test. Is 3 less than 2 plus 2? Well, in other words, what it's saying is 3 less than 4. That's clearly true. Next one on the bottom. Is 2 less than 3 plus 2? Well, it's 2 less than 5. That's what it's saying. That is clearly true. Lastly, is that black 2 less than the blue 3 and the red 2 put together? Well, that is, in other words, 2 less than 5. That is clearly true. So that's working very nicely. All of the tests are true. Let's make a picture out of this. So I'm going to draw a circle, radius 2, another circle, radius 3, and then somewhere on that bigger circle, put a point, like right there above my head, and draw a second circle of radius 2. You see, like this. And now, make a triangle. How would you make this triangle? Well, again, you're going to begin from the inner circle center. Then you're going to draw a segment from here. So from that center point over to the rim of the outer 3-unit circle. And lastly, just connect them this way. Take a look. So you see it connects over here, and you know that's 2 units also because this circle where I am inside of now is actually the same as this circle where I am inside now. So in other words, from the center along the red line to here is 2 units, but also from where they meet over to that other center is also 2 units, perfectly 2 units, you see? And then also this is 3 units. So this kind of construction allows you to draw these triangles with complete precision. I like this. I was just kind of playing around with different shapes and I kind of stumbled upon this. I'm sure, it's standard construction. Maybe I forgot about it at some point, I don't know. Take a look, there's one other interesting thing that we can study here. If you just look at this, you see clearly that this is not the only triangle that can be formed this way, because I can just as easily go from where my head is over to this intersection point, and then over to that intersection point, and I could construct another triangle just like this. I want to stress this, that blue point above my head, there's nothing special about putting it there though. This could be repeated, for example, if you put that same point there, you see? We just want to be able to measure off distances perfectly, that's the goal. Let's take a look at another case. So here I have 1, 2, and 3. The question is, can you make triangles out of these? So let's see. I'm going to do some basic tests. Is 3 less than 2 plus 1? Well, clearly that's false. On the bottom, is 2 less than 3 plus 1? Well, is 2 less than 4? That's true. On the bottom still. Is 1 less than 3 plus 2? Well, 1 is less than 5 is certainly true. How do you visualize this to convince yourself that this actually does not make a triangle? So you make a circle. Make it, for example, radius 2. Around it, place a circle of radius 3. Then somewhere on that circle of radius 3, place a circle of radius 1. So for example, I'm going to do that right here above my head, just to show you it's a completely different location compared to the other ones. Above my head, there's a little blue dot. And on that dot, I'm going to center a circle of radius 1, so that looks like this one right here. And you can tell something, take a look. So now draw the red line. That represents basically the radius of the circle here, of the inner 2-unit circle. So that's 2 units. Then draw another one. The blue one, if you think about that, I know it looks like it's a little segment that goes from where my head is over to the point, but that's not true because remember, everything is drawn from the center of that 2-unit circle. It's just that the portion of it there is behind the red line, so it's not visible. But it's actually going from the center there over to that center point on the rim. So that whole thing is still 3 units. Now the question is, where's the 1 unit here? Well, remember the 1 is really the radius of that smaller circle, so that goes right there, you see? At this position, this is no longer clearly a triangle because you see that 2 plus 1, those two added together give you 3. And that's not a triangle anymore. In fact, because they're equal, it just kind of generates on a line, which is clearly not a triangle. In other words, that shows up here by saying that, for example, is 3 less than 3, well, that's a false statement. But geometrically, it kind of gives you this nice line in that position. So these are some of the interesting things that you can do with the triangle inequality and then using circles to construct triangles. This is kind of like just really the beginning, and I have a feeling that a lot more can be done with these concentric circles or the circle on the circumference, for example. But that's it. Thank you so much. Please leave a like and subscribe. I'll see you in another video.